And welcome to our detailed video about fields, features, and much more. Coronal holes, solar flares, close-ups of the closest star. A regular feature at the Smash News Network, least busted name in news. First thing we're looking at are the Geospace Magnetosphere movies. So this is Earth's magnetic moment from space. The scale that you're seeing modeled here is nanopascal, magnetohydrodynamic pressure. And it should be over the last 4 hours if all things are working appropriately. You can see most of the pressure here is in the magnetotail side, the dark side of the planet. As we've been seeing the subsiding of a coronal hole wind stream, the plasma is trying to reach static equilibrium, as things do in the realm of thermodynamics. Here are the GOES magnetometers over the past 3 days. A little bit of spiky readings there. It was a pretty weak coronal hole wind stream. We can expect more to come in the coming days. Next, Earth's magnetic moment from the ground. So this is scaled in nanotesla, this space weather modeling framework animation, courtesy of University of Michigan. Like the Geospace Magnetosphere movie, the ground magnetic perturbations map is the last 4 hours of data, put in this convenient Earth magnetic moment from the ground. Nanotesla magnetic flux density. And nothing too crazy going on there. Let's continue on. It gets pretty crazy during geomagnetic storms, and we haven't really seen any for a while here. We are seeing a little uptick here in the solar wind speed happening. It's come up from its lows in the past 24 at about 430 kilometers per second. Now it's up to about 460 kilometers per second. Solar wind density about 5.5 protons per cubic centimeter. Everything else fairly unremarkable there on the real-time solar wind. KP index, a measurement of global geomagnetism, is at 2. A KP2 is the current geomagnetic calm condition that we're seeing. And I was wrong about the heliospheric current sheet. So if you look at the last image here, you can see the South Pole current sheet is almost here, but not quite. We expected it to be here by today. It could have involved the complexity of Sunspot 2974, which produced an M-class flare. You can see the North Pole current sheet shown there in green. Let's reanimate that, as I am the reanimator. This data 1 hour and 14 minutes old from when we recorded the video. Keep in mind the magnetic environment can suddenly change. Tomorrow, when we make our space weather video, we will have a South Pole current sheet. Sometime between today and tomorrow, Earth will cross into the South Pole current sheet. So this is a line-of-sight view of the same data, essentially. It also includes the solar magnetogram, since we're at the line-of-sight perspective. South Pole current sheet is imminent, as Sunspot 2975 wins the magnetic tug-of-war for the polarization of the heliospheric current sheet. Next, the line-of-sight coronal hole plot. You can see South Pole-oriented coronal holes rotating in here, shown in red. We've got trans-equatorial coronal holes of both polarities here. As the solar cycle 25 progresses, those magnetic fields reverse. They move from the polar regions to the opposite polar regions. Sun's B field shown in this animation in blue. And let's take a visual analysis in ionized iron from the SDO. There's 193 angstroms. Very well-defined coronal hole, and we can expect an extended high-speed stream from that. You can also see an M-class flare happening, and the shock waves reverberating across the surface of the sun. You can see radial ripples coming out. I'll let that play through one more time before we show all kinds of fantastic close-ups. And there you go. That was an M-class solar flare. Next, moving on to sunspots. We've only got 2 named groups, it looks like, at the moment. Sunspot 2974, which produced that M-class flare early this morning, and Sunspot 2975, which is just gigantic and has actually grown since yesterday. Likelihood of major flares, you can see more likely than not, making it all the way up to 72% there. Don't be surprised to see an M or even an X-class flare. Sunspot 2975 is huge, magnetically complex, and beta-gamma class, the kind associated with large solar flares. So here it is in all its close-up glory. It has gained a little complexity here in the past 24 hours, which is the time frame you're seeing. Those leading umbrae there, you can see them growing in the past 24 hours. 2974 to its south is the one that produced that M-class flare, and you can actually see the flare there. A sudden brightening around that moment, and we'll get to more specifics about that in a moment. Here's the full disk view first. So lots of activity in the east, no activity in the west. Peak flux of that M-class flare, which was an M1.4 class flare. That was around 5:30 universal time. And we'll show the coronal mass ejections, which we think are, including some Earth-directed plasma. No spikes in the proton flux, though. It didn't send any relativistic particles that have made it to Earth yet. Looks like it's probably not going to happen. It did cause some radio blackouts. If you want to check those out, head to the Space Weather Prediction Center and click on the deabsorption region imagery. Let's see, where is it? The D region absorption predictions will show you radio blackouts when they occur because of solar flares. We won't worry about it at the moment. Here are some slow-mo close-ups of that solar flare. Huge coronal hole visible there as well. This is 193 and 171 angstroms composite. You should see a great rippling there following that M-class flare. We slowed that down to 15 frames per second for you. And you can see that shockwave making it across the sun and then sort of subsiding as it reaches that coronal hole region. Just spectacular imagery there. Here's some more in 131 and 94 angstroms. Two of the best wavelengths to view solar flares. We'll look even more closely after that plays through a second time for you here. There you go. M-class flare. And here's a close-up in this 15 frames per second speed. Next, a solar system forecast. We're going to show you where things will be in a week. And we've got a planetary pile up in the morning sky. If you're up before dawn, go check it out. Venus, Mars, Saturn, Jupiter, and Mercury all showing up over there. There's where things will be in a week. We'll have a new moon on April Fool's Day. Here's a star chart from in-the-sky.org. The blue line is the galactic plane. The yellow line is the ecliptic. And again, rising here in the Lehigh Valley, we've got the Sun, also Mercury, Jupiter, Saturn, Venus, Mars, and the Moon. Last but not least, we'll look at the coronal mass ejection that we do expect to see some Earth strike happen. Most of the ejecta will miss. It's quite diffuse, but it is high speed, so the radio burst was estimated to be about 970 kilometers per second. This is the view from stereo A and from the LASCO C2. So peak flux was at 5:30 for that solar flare, and you can see from stereo A, you can see some ejecta there, sort of in the earthly zone. Earth would be off in this direction from stereo A's perspective. From the LASCO's perspective, Earth would be behind you. And if we look at the LASCO C2, it does look like most of the ejecta will miss to the east, but I think there is an earthly component to that. If it does strike, it'll be short-lived because it's quite diffuse, as you can see here on the stereo A imagery. It's not a very dense coronal mass ejection. We don't see a whole lot on the entire coronagraph there, so there might be some disagreement about this. That's perfectly fine with us. And we hope you enjoyed our daily space weather video. Make sure you follow us on Twitch and on BitChute. There's all kinds of exclusive content going all around the internet these days. Visit our sites at smashamash.com. Become a member of the Smash team. Thanks for tuning in. May that solar wind be at your back. I've been your host, Dan, a.k.a. Smashamash, signing off from the Smash News Network, least busted name in news.